Thank you for all your hard work on behalf of all the American people, keeping us safe. I know it's been very little sleep and very little else, but we appreciate it, Doctor. Thank you. Thanks. It's nice to be with you. All right, in the meantime, we'll be exploring this a lot more on our live show tomorrow. By then, we might know what progress they're making on that stimulus front. We've got a who's who of players that very much involved in this, including where this goes if we get stimulus and if we keep the government lights on.
Hello, everybody. I'm Jesse Waters, along with Juan Williams, Dana Perino, Greg Gutfeld, and Dagan McDowell. It's 5 o'clock in New York City, and this is The Five. Joe Biden has spent the last week dodging tough questions about the federal investigation into his son Hunter's taxes and foreign business dealings.
Hello. Can you hear me?
Yes.
Okay. So we are going to go over chapter 5. Anybody has any question on chapter 4 that you might want us to consider before moving on? So in chapter 4, we learn about the basic theory of probability, the type of probability, and we learn particularly about the classical probability. So in chapter 5, we will move to something a little bit more advanced, probability distributions. As I said in chapter 1, a random sample is a sample which is representative of the population, meaning that it is every member of the population can be part of that sample. So we are going to learn about binomial distribution, which is an example of probability distribution, which is what will help us to connect back to statistics. So we said in chapter 1 that a variable was a quantity that will change from an individual to an individual. And now we are going to look at a special type of variable, which is called a random variable. Starting with a probability experiment, we have outcomes from probability experiments that are random outcome. We can decide to associate to each outcome of a probability experiment a number that is called a random variable. For example, if we toss a coin, we can say that head is 1 and tail is 0. So 0, 1 will be a random variable resulting from the experiment consisting of tossing a coin. So each time we have a random experiment, we can construct a random variable from that random experiment. For example, when a die is rolled, we can decide to just write down the number on the die. That will be a random variable. If you get to a bus stop and you are waiting for the bus, the time you will be waiting is a random variable because it is not a fixed time. So the first random variable, when you toss a coin twice and count the number of heads, is a discrete finite random variable because it has 3 values. If you roll a die, you have 6 values, 1, 2, 3, 4, 5, 6. And the time until the bus arrives is continuous because it's an interval of time which can take any point on the line. So once we have a random variable, we can decide to find the probability for each value of the random variable. That probability is called a probability distribution. We define a probability distribution as a function from the sample space to real numbers that associate to each value of a random variable the probability of getting that random variable. It has the properties that it is a probability, so it's between 0 and 1. And the sum of the probability for a random variable is always 1. That's the characteristic of what we will call a discrete random variable. So if we consider the random variable defined by the numbers that is on a die when it is rolled, we get 1, 2, 3, 4, 5, 6, and the probability of getting each of those numbers is 1/6. So it is a uniform distribution. If we think about tossing a coin twice, we get the random variable y equal to 0, 1, 2. I will use the whiteboard to explain how to find that distribution. So when we toss a coin, we could have head, tail, head, tail, head, tail. That's if when you toss a coin twice. So these are the outcome: head, 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 tail, tail, head, tail, tail. Now I will make a table here representing the number of head. We can have 0, 1, or 2. So what is the probability of getting 0 head? Is only this outcome for 0 head. So it's 1/4. Now the probability of getting 1 head, we have 1, 2, so which is 2/4, and it is half. And then the probability of getting 2 head is this last one, which is 1/4. So you can observe here that the sum of the probability is 1/4 plus 1/2 plus 1/4 equals to 1. That's what we meant by sum of p of x is always 1. When you add the probability of a random variable, you should get 1. That is a characteristic of a probability distribution. We go back to the PowerPoint. So just like we did for a frequency distribution table, when we have a probability distribution, we can compute a mean and the variance of the probability distribution. And from the variance, we can also have the standard deviation. So I'm going to go back first to the whiteboard to define the mean and the variance. So if we have a random variable x with a probability distribution p of x, then the mean of x is denoted by e of x or mu x, which is x times p of x That is, multiply each value by its probability and add them up. So this will be like x1 times p of x1 plus x2 times p of x2 plus xn times p of xn, and so on. Example, if we take the random variable 0, 1, 2, x p of x, 1 over 4, 1 over 2, 1 over 4. Then the mean of x, we write it e of x because we also call it expectation of x, is 0 times 1 over 4 plus 1 times 1 over 2 plus 2 times 1 over 4. And this will be 0 plus 1 over 2 plus 1 over 2, which is 2 times 1 over 4. And this is equals to 1. So the mean of x is 1. So the mean is obtained by multiplying the random value by its probability and add them up. Now about the variance. The variance of x is denoted by sigma square x, or variance of x. And it is equal to the expectation of the square of the deviation from the mean. So we can also write it as e of x squared minus mean square, where e of x squared is equal to the sum of x squared times p of x. So as an example, if we take the values, just 1 minute. If we take the value 0, 1, 2, if we take the value 0, 1, 2, let me check this, I'm sorry. This is the random variable that we did for tossing a coin and having to count the number of heads. So e of x, we want to find the variance of this distribution. Remember that the mean we computed was 1. Now to find the variance, we first need to compute e of x squared. This is not the method that is on your PowerPoint, but this method is much easier to use. You first find e of x squared by squaring each value. 0 squared times 1 over 4 plus 1 squared times 1 over 2 plus 2 squared times 1 over 4, which is equals to 0 plus 1 over 2. 2 squared is 4 over 4 plus 1, which is 3/2. Now we can find the variance. The variance is E of x squared minus E of x squared. Or you can write it as E of x squared minus mu squared. E of x squared is 3/2. And E of x is 1. Square it is 1. This is 3/2 minus 1, which is 1/2. So to find a mean, you multiply each value by its probability, add them up. To find the variance, you find the mean of the square of the values, and then subtract the square of the mean from the mean of the square. That is the meaning of this expression. You subtract the square of the mean from the mean of the square. Remember that the original formula that you will see on your PowerPoint is that the variance is the mean of the square of the deviation from the mean. And we can also express it as E of x squared minus E of x squared. So as we have random variables, we will often need to transform those random variables into other random variables. One of it is the linear transformation of the random variable. The linear transformation of the random variable is L equals to A plus BX. So if we have a random variable X with mean, mu, and standard deviation sigma, I will explain this using the whiteboard. So let X be a random variable with mean, mu, and standard deviation. Remember, standard deviation is the square root of the variance. Then L equals to A plus BX is a random variable. And the mean of X, let's call it E of L. The mean of L is A plus B times the mean of X. Also, the variance of L is B squared times the variance of X. Sometimes we write AX plus B, sometimes it's A plus BX. What is important is that for the variance, the coefficient that is isolated, which is also called the intercept, is gone. And the standard deviation of L is absolute value of B times the square root of the variance, which is B times sigma. Example. Example. Let x be a random variable with min mu equals to 3 and standard deviation equals to 2. Let L equals to 4x minus 5. Then the mean of L will be 4 times mean of x minus 5. The mean of x here is 3. 4 times 3 is 12. 12 minus 5 equals to 7. Now the variance of x, the variance of L will be, for the variance, you only consider the term with x, and you square 4 to have 16 times variance of x. Which is equal to 16 times 2 square, which is 16 times 4, equal to 64. And the standard deviation of L will be 8. You can observe here that it's just 4 times 2, but we take the absolute value because we are going to square it before we take the square root. We can also combine two random variables in terms of linear combinations. Of random variables. If we have two random variables x and y, let x and y, or x1 and x2, be two random variables, then w equal to ax1 plus bx2 is a random variable. And the mean of w is a mean of x1 plus b mean of x2. And the variance of w here will be a square variance of x1 plus b square variance of x2, provided x1 and x2 are independent. This can only happen provided x1 and x2 are independent. In this class, we are only going to be dealing with independent random variables. When we will have to combine two random variables, you will assume that they are independent. Example, suppose mu1 is equals to 2, mu2 is equals to 3, sigma 1 is equals to 3, sigma 2 is equals to 4, and w is equals to 6 x1 I'm having a trouble here erasing. I'm just trying to see if I can fix that. So I want to consider random variable x1. I will write it again. mu12, sigma 1, 3, mu2, 3, sigma 2, 4. And now have w equals to 6x1. I want to say minus 5x2. Then the mean of w will be 6, mean of x1, minus 5, mean of x2, which is 6 times 2 minus 5 times 3 equals to 12 minus 15 equals to minus 3. And the variance of w will be 6 square times sigma 1 square plus minus 5 square. Let me observe here that we square the coefficient of the second one, even though it was negative, it's going to change to positive. This is 36 times 9 for sigma 1 square plus 25 times 16. So W is equals to 36 times 9, 324, plus 25 times 16, 100, which is 724. And the standard deviation is square root of 724. If you have a question, just let me know. So you can have a linear combination of two random variables if they are independent. For the mean, you don't need independence. For the variance, you need independence. I will quickly go back to your PowerPoint and we will see the example which is on the PowerPoint, because this example, I made it up. I will quickly go through the ones that is on your PowerPoint. Let x1 and x2 be independent random variables with respective means mu1 equal to 75 and mu2 equal to 50 and standard deviation sigma 1 equals to 16, sigma 2 equals to 9. Let L equals to 3 plus 2x1. Compute the mean, variance, and standard deviation of L. Here, we will use the linear transformation. Mu L is 3 plus 2 mu1, which is 3 plus 2 times 75 equals to 150. And the variance of L will be 2 square, which is 4, times 16 square, which is 1024. and you find the standard deviation by taking the square root of the variance. Let W equal to x1 plus x2. We want to find the mean, the variance, and standard deviation. So this is the linear combination of two random variables. The mean is just the sum of the mean. And the variance is also the sum of the variance because the coefficients are 1. So when you square them, they remain 1. So this happened like that because it is x1 plus x2. Now let's think about W equals to x1 minus x2 for the same values. The mean will be the difference, but the variance again will be the sum of the variance because -1 will be squared. And we will have the same standard deviation, even though it is a minus here, because the formula requires that you square the coefficients of the random variables. Let's look at the third one. W equals to 3x1 minus 2x2. Find the mean, variance, and standard deviation. The mean is 3, mean of 1, minus 2, mean of 2. That is 125. And the variance is 3 square, variance of the first one, plus minus 2 square, variance of the second one. So that's how we get 2628, taking the standard, the square root to get the standard deviation, 51.26. And so binomial experiment. A binomial experiment is the probability experiment which is made of a fixed number of trials. We have a fixed number of trials, which is n. Trials are independent of each other. Each trial has exactly 2 outcomes, success and failure. The probability of success at each trial remains the same, and it is P. And the probability of failure, 1 minus P, is usually denoted by Q. So in general, we are interested in finding the number of success in a binomial experiment. For example, if we decide to toss a coin 10 times, it will be a binomial experiment. N will be 10. If success is head, then the probability of success will be half. So in general, we are interested in the probability distribution of a binomial experiment. Which formula you can see there. I am going to explain that on the whiteboard. So on a binomial experiment, we have 3 quantities. N is the number of trials. P is the probability of success. And X is the number of success, which defines a random variable called the binomial random variable. And probability P of success is used to define the probability distribution of a binomial experiment. So X is the number of success. So we are generally interested in the probability of how many success do we have. What is the probability that the number of success is K? It is equals to N combination K, P, K, Q, N minus K. So we will not be using this formula too often because you can use your calculator. Your calculator has a binomial distribution formula, which I will recommend that you use rather than using this formula, which most of the time is a little bit complicated. For example, if we say that we want to toss a coin 3 times and count the number of heads, then we have a binomial distribution. Remember, we had outcome head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. So of these 8 outcomes, we can construct our binomial distribution 0, 1, 2, 3. There are 3 possible number of head that we can get, x, p of x. Then 0 head is all tail, is 1 over 8. 1 head, it appears 3 times, 3 over 8. 2 head is also 3 times. This is a binomial distribution for the number of head. So we can use this formula, for example, to find the probability that x equals to 2. It will be 3 combination 2 times probability of success is half square and then 1 over 2. 3 combination 2 is 3 factorial, 2 factorial, 1 factorial, and then 1 over 4 times 1 over 2, which is 3 over 8. Do you have your TI 83 or 84 calculator? Any of you? Anybody has a TI calculator? I
don't have it with me right now. I'm not sure where it's at. I misplaced it.
Okay. And so anyway, for those who has TI 83, to use it, you go to second function on the TI 83 calculator. If you go to second function, you will see the distribution under VARS, and then you will choose, you will go down to binomial distribution. And then when you get to binomial distribution, you will see binomial PDF, and you write NPK. N is the number of trial, in this case is 3. P is the number of success, in this case is 0.5. And K is the number of, P is the probability of success, and K is the number of success, which in this case is 2. Then you find the probability and you will see 0.375, which is 3 over 8. So you can use your calculator. Or you can also use, if you go to Google on your laptop, you can find a binomial distribution calculator. It's good to always be with your calculator as we are moving on. Calculator will become more and more useful. Let's look at this example. Privacy is a concern for many users of the internet. One survey showed that 59% of internet users are somewhat concerned about the confidentiality of their emails. Based on this information, what is the probability that for a random sample of 10 internet users, 6 are concerned about the privacy of their email? So here, n equals to 10, p equals to 0.59. I'm going to use a binomial distribution calculator. From Google. I hope you can see my Google. I'm going to type here binomial distribution. I will see binomial distribution calculator. Then I click on one of them. So do you see the binomial distribution calculator that I have? Are you seeing my Google page?
Yes.
Yeah.
Okay,
Yeah.
so in the example that we had, we wanted the probability that there were 6 success. So here, probability of success on a single trial, this is P. It was 0.59. I type here 0.59. The number of trials was 10. And the number of success in our question is 6. Once I have this, I press calculate. It gives me several answers. So because you are not using your calculator and I am showing you how to use this Google calculator, for x equals to x is the probability that exactly 6 people out of those 10 will say consent about their privacy while using the internet. That is equal to exactly. If you had the question, what is the probability that less than 6 people are concerned about their privacy when they use the internet, less than x, you will have 0.39. If the question was at most x, that is less than or equals to 6, you will have 0.64. If it was greater than 6, you have 0.35. If it is greater than or equal to 6, which is like at least 6, 0.6. So depending on the question that you have involving the binomial distribution, you can use the Google calculator to get the answer. So generally, this one, probability that x is less than or equals to, is called the cumulative probability distribution, which I'm going to move back to, or move back here, and we will see what are the questions that we had. So you can remember that we had 0.05. I will go back to it. Probability that x equals to 6 is 0.05. That is what we have here. X equals to, when it's equals to 0.025. Now let's go to the next question. Oh, sorry. Anyway, you could use a calculator to do that. That is what information you have here. You also have a binomial distribution table at the back of your book, which you can use. If you go to that table, you will see for each case, you will see a table like this. So here are the probabilities, but you can observe that the probabilities that we have here are just these ones, 0.01, 0.05, 0.1, 0.15, 0.2, and so on. If you have a probability like 0.59, you cannot use this table. And then you will have the sample, the number of trial here, like in this case is 6, and the possible number of success. If the question was, what is the probability that P equals to 0.5, N equals to 6, and X equals to 4, then you will see here 0.234. And if you had the question that what is the probability that X is less than or equals to 4, you will add the 4 numbers. If you were the probability that X is less than 4, you will only add for 0, 1, 2, and 3. So all of these, you can also get them using your Google binomial distribution calculator. Let's, assuming that you can use your calculator to do this, I want to move on. Additional property of binomial distribution. We want to know the mean and the standard deviation of a binomial distribution. It's as simple as the mean is n times p, and the standard deviation is square root of npq. So on a quiz, if I give you a binomial distribution and ask you to find the mean, is np, the number of trials times p, the probability of success. And the standard deviation, the variance is npq, the standard deviation is square root of npq. For example, let's compute the mean and standard deviation of the distribution of example 7 that describe probabilities of a lone diners leaving tips on a green spot restaurant. In that example, n was 6, p was 0.7, q was 0.3. So the mean is np, that is 6 times 0.7, 4.2. So the standard deviation is square root of npq. N is 6, p is 0.7, q is 0.3. So quarter problem is one type of application of a binomial distribution. In a quarter problem, you are interested in finding the minimum sample size so that you can achieve a certain number of success. So in a quarter problem, you will have a lot to deal with at least. So you want to remember that when you say at least 1, the opposite is 0. So I want to explain this one on the whiteboard. So the question in a quarter problem is, what is the minimum sample size or the minimum number of trials? So that we are 6. When I say C 100%, it will mean that if I say 95%, C will be 0.95. If I say 90%, C will be 0.9. C times 100%, we are confident that the number of success is at least K. And that is, we are saying that the probability that the number of success is K is greater than or equals to C. So what is the minimum sample size? For example, you might be working with a company as a sales agent, and you are requested to sell a certain minimum number of items. Maybe you must sell at least 3 of them. And you want to know how many customers should you call to be 95% confident that you will sell at least 3. How many customers should you contact to be 95% confident that you will sell at least 3? So that question will be probability that X is greater than or equal to 0.95. So to solve this type of problem, because you don't know N, you will be trying and error. You will be trying until you get to the right minimum value. Because you don't know the number of trials, we will transform this problem into the opposite of this. The opposite of this is probability that X is greater than or equals to K is 1 minus probability that X is less than K is greater than or equals to C. So that will means 1 minus C is greater than or equals to probability that X is less than. So we will essentially be looking for n, so that probability that x is less than or equals to k minus 1 is less than or equals to 1 minus c. This is how we will be working on solving a quarter problem. It will be essentially finding n so that we resolve this. Let's look at an example from your PowerPoint. In this example, we will be dealing with junk bonds. Junk bonds can be profitable. They are like junk cars, cars that have been into an accident. Junk bonds are like companies that would have done well but have bankrupt. Why are investors willing to consider junk bonds? Suppose you can buy junk bonds at a tremendous discount. You try to choose good companies with a good product. The company should have done well, but for some reason did not. Suppose you consider only companies with a 35% estimated risk of default. That is, they will fail at 35%. That actually means that they have a 65% rate of success. And your financial investment goal requires for 4 bonds to be good, in the sense that they will not be default before a certain date. Suppose you want to be 95% certain of meeting your goal. How many junk bond issues should you buy to meet this goal? Actually, we are trying to find out what is the number of bonds that you should buy to be 95% confident that at least 4 of them will not default. If they have a 35% rate of default, the probability that they will not default will be 65%. So we will now say that we want the number of success R to be greater than or equal to 4 at 95%. That is what we had on the whiteboard. So probability that R is greater than or equal to 4 can be expressed again as probability that 1 minus R less than or equals to 3, which is actually less than 4, because if it is less than 4, it's less than or equals to 3 in a binomial distribution. Is greater than or equals to 0.95. So we are now solving the problem of what is the probability, what is the number of trial n, so that the probability that R is less than or equals to 3 is less than or equal to 0.05. Remember that the probability of success is 0.65. So we can either use calculator or use the probability distribution. So you can try n equals to 7, you will see that you will not meet it. 8, it will not work. When n equals to 9, it will not work. But when we get to n equals to 10, we get 0.025. So the probability that x is less than or equals to 3 when n equals to 10 is 0.026. When we try 9, we will see that the probability is when n equals to 9, if we can put it on the Google calculator. Here we have, remember, we have p equals to 0.65, we have k equals to 3, and then we are going to try a couple of values to see which of those values will have their probability less than or equals to 0.05. Remember, we want it less than or equal to 0.05 because of the 95% confidence. Let's go to that. Let's use this calculator. So the probability of success here is 0.65. So we will be changing the number of trials. The number of success here, we want it to be less than or equals to 3. So we will be looking at 1, 2, the third one, p of x less than or equals to x. So I will first take 6, for example. That is randomly. I take n equals to 6. At n equals to 6, I have the probability to be 0.35, which is greater than 0.05. My aim is to get a probability that is less than 0.05. I will change the number of trials to 8. And I have here 0.1. 0.1, it is still bigger than 0.05. So 8 is still too large. I will get to 9. As you increase, that probability is supposed to be reducing. When I get to 9, I get 0.05. I know 10 will work, but I will try 11. When I try 11, I get 0.01, which is less than 0.05. If it was at 11, I will reduce it to 10 because I'm looking for the minimum. When I reduce it to 10, I get 0.029. Remember, 9 failed, 10 was successful. So the answer is 10. So using this calculator is much easier than the table or your TI-83. Since all your exams are open book, whenever you have such a question, you want to know the probability, the confidence level. If it is 95%, your maximum should be 0.05. And you will want, if K equals to, let's say K equals to 5, you will use 4. If K equals to 4, you will use 3. If K equals to 3, you will use 2. It will decide how to find a minimum number of trials. So 5.4 is optional. You can go over it. So you are not going to get questions on 5.4. So for that reason, I want to stop here. Do you have any question? If you want to learn about 5.4, this PowerPoint is an audio PowerPoint. You can listen to it on your own. So essentially, we have learned about probability distribution. You start with a probability experiment and associate to each of them a number. Now that number, you can find the probability of getting it. It defines the probability distribution. We find a mean by multiplying each random value by its probability and add them up. We find a variance by finding the mean of the square of the value and subtract from it the square of the mean. The standard deviation is the square root of the variance. We learn about a linear transformation and a linear combination of random variables. You will have questions on quizzes on those ones. And you have very few questions on the quota problem. You have some questions on the mean, variance, and standard deviation. Remember that for a random variable, for a binomial distribution with number of trials n and probability of success p, the mean is np, and p, mean is np, variance is npq, where q is 1 minus p. Standard deviation, square root of npq. Any question? If you don't have a question for now, remember you can always send me an email and you can start working on your homework and make a first attempt. Always contact me after your first attempt for questions that you don't understand why you got wrong. Don't wait until the second when you will not only have 2 attempts. I'm sorry, when you will only have 1 attempt. And worse, don't ask me question at the 3rd attempt because it is not going to change your quiz. So after your first attempt, if you don't understand an answer, just contact me. Okay. Okay, we are done, and
Thank you.
you're welcome.
Thank you.